So in this video, what we are going to talk about is the best case and the worst case again. Best case and the worst case. So we will have to find what is the best case and what is the worst case. And there is another thing, we need to find the number of basic operations, in best case, the count for the number of basic operations in best case. So this C over here represents count. It says count. I didn't give you the representation for n. I didn't tell you what is n. So Cn, you have to count the number of basic operations when your program ran for best case, and also you have to find the count when your program ran in the worst case. Okay, in the worst case. So you know that the best case is the one where you manage to have the computer to run least possible number of statements, and the worst case is where you push your computer to run maximum possible number of statements. Okay, and in this question you have to tell what would be the best case and what would be the worst case, and along with that you have to count the number of operations, basic operations, in those cases too. So let's say we have a program over here. Let's say we have a program which takes again which takes input from user and stores it in variable a, and it then checks for some couple of conditions. Let's say if a modulus 2 is exactly equal to 0, then print a is even. Else if a modulus 2 is exactly equal to 1, print a is odd. So essentially these two mathematical expressions over here, these are for checking whether a number is even or a number is odd. And for those who do know, or for those who don't know, an even number is like the one like 2, 4, 6, and the odd numbers are like 1, 3, 5, 7. And the way to check these number, whether a number is even or odd, is by dividing them by 2 and checking for the quotient and the remainder. So for example, I'm going to teach you how do you check for whether our number is a 2, whether our number is a even or an odd. What do we mean by this operator over here? Okay, for those who don't know what does modulus do, for those guys I'm going to tell you what does the modulus operator does. So you have all seen like how to do the basic division, right? So we used to do like in our kindergarten, or like some, I don't know, primary classes. So we used to have, let's say 4, and we used to say, okay, let's just divide 4 by 2. Okay, so we used to do this table method, and we used to say, okay, 2 times 1 is 2, 2 times 2 is 4. So we used to say, okay, this 2 goes up here, and 2 times 2 is 4, and now we are done. The remainder is 0. Okay, and yeah, that you used to call this the quotient, okay, and we used to call this one the remainder. So whenever you see the modulus operator like this, a modulus 2 is equal to what? So this question over here is asking what is the remainder? What is the remainder after you have divided a by 2? Okay, so whenever you see the modulus operator like this, you have to divide the number by the number given. Like in our case, like for example, I use this example, so you have to divide 4 by 2, and you have to focus what would be the remainder, and that remainder would be the answer over here. Okay, so now let's come back to our original problem, and I'm gonna clear this stuff. Okay, so we have to take input from here. So the user is sitting in front of the computer. The user is sitting in front of the computer over here, and the computer is running this program. Okay, it is running the program, and the user passes in the value of let's say 2. The user passes in the value 2. Okay, what's going to happen now? So we were at this statement, we took the input from the user, so we managed to run this statement, take input from and store it in a, and now we are at this statement. The computer is at this statement. What's going to happen at this statement? This statement asks us to divide the value of a by 2 and then check whether the remainder you get after dividing a by 2 is exactly equal to 0. Okay, so let us check. So the user gave us 2 and we have to divide it by 2. Okay, so we are gonna do the table math. So 2 times 1 is 2, so this one goes as a quotient, and there you go, and the remainder is indeed 0. Okay, so the remainder is indeed 0. So 0 is exactly equal to 0, and the if returns us true. And since the if returns us true, we will be running the corresponding if block over here. Okay, we will be running the corresponding if block over here. So how many statements have we run so far? 1, 2, and 3. And since we managed to run this statement, now we will be skipping this else if, and I have given a complete tutorial about this, like how do you run the if in combination with else if. So I have given the whole tutorial, but just to summarize, if one of the if returns true, the corresponding if block runs, and the rest of the else if statements is gonna be skipped. Okay, so now we managed to run this statement 1, we managed to run this statement, so the total number of statements 2, and we did manage to run this statement, so the total number of statements we ran so far is 3. Okay, how about we will just write this over here. So when the user gives in 0, statements count is 3. Statements count is 3. How about now? If you notice, this is the best case. Because think about it, you, no matter what, you will always run this statement, take input. You cannot skip this one because it is not inside some if. Okay, it is not some inside some if else, it is not under any condition. So the computer is going to enter, and the first statement is going to see, is going to take input for A. Okay, so that's going to happen for sure. And depending upon these statements, we're going to decide the future for these. Okay, the other statements. So since the user gave us this value of 0, we checked whether the remainder after the division is 0, and we did our calculation over here, and it was indeed 0. So 0 is exactly equal to 0, which turns out to be true. So we did run the print statement, and since we managed to run one of the if, we will skip the rest of the if blocks. Okay, so the total number of statements is we ran so far is 3. So the total number of statements we ran so far are 3. Okay, cool. So that was the best case. Okay, that was the best case. And I didn't give you the data though. I didn't give you the data. So let's just assume that if takes 1 unit of time and print takes 1 unit of time. So I'm assuming this. So in best case, so we will write the answer now. So the best case is 1. The best case is the one when user passes in 0, and the count is 3. So now we are going to move to the second part, which is finding the worst case. So the worst case is the one where we will manage to push the computer to run all the way down. Okay, we will push the computer to run maximum number of statements. Okay, so keep that in mind. So do you have any example, or can you come up with something that's gonna push the computer to run all the way down? Okay, this means we shouldn't be stopping at this point. So if we will stop at this point, it's gonna run this statement and it's gonna stop. So this means we shouldn't be passing the value of any even number. Okay, if we will pass any even number, it's gonna check whether it's even, and it's gonna return even, and it's gonna stop at this point. So my we noticed that if we pass some odd number though, it's gonna skip these statement in, I mean, it's not gonna skip these statement, it's gonna be pushed down more than before. Okay, let's try this one. Okay, so the user sits down and user passes in the value of 3. Okay, what's gonna happen now? Let's just clear some of the stuff over here, this stuff, and I don't know, I think it's gonna be hard to just remove this stuff. There you go, but still there you go. Okay, cool. So let's say we did give the value of 3. So now A is equal to 3. So we did run this statement. So we're gonna add 1. Oh, okay, we run one statement. How about then the computer moves to the second statement, and it's gonna check whether if 3 divided by 2 returns us the remainder, which is equal to 0. So I'm gonna just be dividing 3 by 2. So 2 times 1 is 2, 2 times 2 is 4, which is greater than 3. So I'm gonna use the quotient 1, and its result as 2, and the remainder is 1. Okay, so the remainder is 1, which is not equal to 0. So I'm gonna skip this one. I did run this statement over here, but now since the value turns out to be false, the result turns out to be false, so I'm gonna be skipping this print statement over here. Okay, so I'm gonna be skipping this one over here, and I'm gonna move to the next else if. So a statement, the computer skips this one and it moves to the next. So we're gonna do the same thing again. So it says else if a modulus 2 is exactly equal to 1, which is asking when you divide 3 by 2, whose quotient would be 1 and the remainder would be 1 indeed. So 1 is indeed equals to 1. Okay, so we did run this statement too. And now because the if returned as true, we will be running this statement over here. Okay, so how many statements did we run? That's 1, that's 2, we skipped this one, that's 3, that's 4. Okay, cool. So in the worst case, the worst case is the one when the user passes in an odd number. Okay, an odd number, due to which the computer is going to be pushed down to return to run maximum possible statements, and the count of operations how many did we do? Like that's 1 and that's 2 and that's 3 again. Okay, cool. I think I counted 3 here because of this one, so let's just count this one. So 1 1 2 no sorry 1 2 3 and 4. Okay, cool. So Cn would be 4. Or I think I did forgot whether I counted this one before or not. So if I counted this one before, then I would say like I shouldn't have counted this one, because according to my given data, I said okay, the Cn should consider like the prints and the ifs. Okay, so print takes 1 and if takes 1 unit of time. So for the best case, we saw that we're going to be running this statement, we're going to be running this statement, and we're going to be running this statement. But since our data focuses on the prints and the ifs, we would say yeah, we did run 3 statements, but the count of operations would be 1 for the if, 1 for the print, and that should be like 2. So that should be 2. And for the worst case, we did run this one, we did run this one too, and this one too. So the number of statements we ran for the worst case was 4, and the count of operations for the prints and ifs is 1, 2, and 3. So it's 3. There you go. So it's 3. So that is another example I have shown you for the best case and the worst case, and I hope you know now how do you deal with an example that asks you about the best case and the worst case. So again, remember, best case is the one where the program has to run where the program is helped to run least possible number of statements, and it is you who have to come up with some scenario, and you just think about this program over here, you see this program, and you try when you have to find the best case, what you do is you try to keep the computer, like you pull the computer backwards, and you help it to just not go down. You just help it to not go down all the way down, so you keep it up as possible. Okay, but when you are looking for the worst case, what you do is you're trying to push the computer down, so that it runs maximum number of statements. And what you have in mind is that you have this goal over here, that I have to reach this statement. So that is how you come up with some worst cases and the best cases.